So here's something we have to know about the impulse formula. This is assuming that the force is constant. You can only use this formula when the force is constant, but once it isn't, you just throw it out the window. So let's graph something. This will be force, and this is time. And if force is constant, this is what the graph looks like a straight line. And we could get the slope of this, which would be the rise over run, and the rise here would be force, and it would be over time. So the slope would be equal to force over time. But that doesn't really tell us anything at all. What is important is the area under the line. If we calculate the area under the line, multiplying the area under the line is really just multiplying force and time. So the calculation for the area here is equal to the impulse acting on the object. So for this, we can see that this is a really bad drawing I've made, but this line here is straight. And force, time. So this y level is 25, and here it's 10 seconds. So if we just get the area of a rectangle, which is base and height, you can get that it is 10 multiplied by 25, which gives us an area of 250, which is equal to our impulse. And if you really wanted to, you could have just done the standard impulse formula, which is F, change in time, because the force is constant. There's no change in the force. So take a look at this question. So as we can see, the force here isn't constant. It increases from 0 newtons to 3012 newtons. So what we should do, the very first step you want to do here is create a graph. Let's make a graph. So this is 5.78 seconds. The force is 0, and then it climbs to 3012. So we can just connect the dots here. Now all we gotta do is calculate the area of this right triangle, and if you can recall that is BH over 2 is equal to the area. So the base here is 5.78, and the height is 3012, and we divide all of that by 2. This gives us an impulse of 8,704.68, and because we need it in 3 significant figures, we can just 1, 2, 3, 8.70 times 10 to the power of 3 kgm per second. We have the impulse, and we must determine the final velocity of the car. So we know that the impulse is equal to the number that we just got, and we also know that impulse is equal to mass times change in velocity. So we can just equate them to each other. Divide by mass. So now just take your result, divide it by the stated mass of the car, 1500. So this gives you 5.80312 is equal to delta V. So 5.8312 is equal to VF subtract VI. And because it says that it's accelerating from rest, we know that the initial velocity is really just 0. So let's add 0 to both sides, and we'll get that the final velocity is 5.80. This is the final velocity, 5.80 meters per second. So for this question, what we're trying to find is the exact y value of this point, because the y values are equal to the force, and this is where the y value peaks, so we must find this. So to find this, you just have to find the height of this entire triangle. So the area of this triangle is base height divided by 2. This is equal to the area. And we know that the base is 10. We don't know the height. And the area is equal to the impulse, and the impulse has been stated. So, and then we just solve for the height. So times 2 on both sides, times 2, 1000 equals 10h divided by 10 divided by 10. And you'll get that the height is equal to 100. So that is the maximum force exerted. Wait, don't say your height is 100 newtons. Say your force is 100 newtons. Now, for a curved line like this, you can't get the exact value because you need calculus, but you can approximate it by just creating a basic triangle, and this will be like approximately similar to the area.